Hello guys, it's Sugarbush here, and in this video I'm going to show you, hold on, wait for it, I'm going to show you how you can make a camera that follows an object, and when you rotate the object, the camera actually rotates along the pivot. Alright, now I do not do this, notice the main camera is not, so this is the player, right here. That's the player right there. And the main camera, notice that the main camera is not a child of the player. Alright, it's all math and calculations that is doing this. It's actually fairly simple. So let's get right into it. So here's a new project that I have. Another good habit I like to do is to bring the near clipping plane down as low as it'll let you do. Just something I'm in the habit of. But anyways, so I've got a little cube right here. Oh, whoops. A cube right here. What we're going to do is make this camera follow the cube. Now I'm going to move it around in a scene view because I don't really want to not going to program a controller for it. So to do this, let's create a new C# script and call it follow target, or whatever you want. So let's open this up. Alright. So now we have a script. So yeah, we've got a new script here. So what stuff are we going to need? Now there are tutorials on this. In fact, there was even one about how to do this exact thing where you make the camera actually pivot or rotate along the pivot. But that included making the camera a child of a center object. We don't need to do that. That's unnecessary. So I'm going to show you. So let's serialize field, transform, target. So this is going to represent the object that we want to follow. Then serialize, we need a position offset. And let's create a vector 3 rotation offset. Yes, I want to use vector 3 and not quaternion, because we can convert it to quaternion. I'll show you that later. So these don't need to be made public in this context. So anyways, let's get this started. So I actually like to use late update for this, so let me show you. So it's actually fairly simple. So transform.position equals target. Well, a lot of tutorials might say target.position plus position offset or whatever. That's not gonna work in terms of like the pivot exactly. That's only gonna be in world space. All right, they're only gonna move like this, and regardless of how the cube is rotated. So here's what we want to do: target.transform point of position offset. Now let's see how that works. Transform point actually does get you this position. So this position, so this is like a local space. It's hard to explain exactly what transform point is. Maybe I'll give a link to a source for that. But anyways, for the main camera, let's put the follow target in. Now the target must be assigned in inspector. Now we're going to put a position offset, I think, yeah, about like -10 and 1, just where the camera is. So let's see how this works in gameplay. So if I move the cube around, you can see the camera's moving. And if we rotate the cube, you can see the camera actually rotates along the pivot, but its rotation is not. Well, we haven't set up the rotation. We never did anything to the rotation yet, did we? Oh, wrong window. We only set up the position. We're not using rotation offset. We are going to use that. So transform.rotation equals target.rotation times, we need this as a quaternion. Now, it might, yeah, so you can't multiply, and even if we could, I don't think that's what we want to do. So we want to do vector 3 to quaternion. We do not cast as quaternion. That's not going to work. There's a function that does this. And that's quaternion.Euler, or Euler, or whatever. Quaternion Euler of rotation offset. And that should get the rotation right. I'm going to put a little quad in. Make it represent. Let me just do a little setup here so you can kind of see where this is kind of going. So now, if we rotate the cube, watch the game view, you can see the camera actually rotates along the pivot. It actually pivots to this, and it's looking right at it. Now we can even put some rotation offset on it, and that offset will remain. So yeah, that's actually it's actually that simple. Now you could do transform.lookAt, but that's not going to include the rotation offset. This is how you do it. It's a quaternion multiplications. Now there's something else I want to show you though. And that is if you want to manually assign, well actually first of all, let's visualize this. Void on draw gizmos. So let's first set gizmos to color equals color.blue. Then we're gonna do gizmos.drawLine, target.position, target.transform point, position off. Now we gotta make sure that target's not null though. Same thing here actually. Otherwise, we're going to get an error. So we're going to check. So now let's visualize this. So now you can see the blue line. If we move the camera, the blue line's still there because the position offset. Yeah, so it's still there. If we move the camera, it's still going to go back to there because we haven't actually set the position offset. Now we're going to actually create a little function that can do that. So let's do public void set offsets. Let's actually make this context menu set offsets. So if you don't know what context menu does, I'll show you. It lets you right-click on this, and it's right there. Now, it's not going to do anything yet. So we're gonna program that. Yeah. So position offset equals, and we got to get the reverse. So we got to do target.inverse transform point of transform.position. So that's basically, this returns us our position, the position of the object that this script is attached to, relative to the target. So let's actually do that really quick. So I'm going to move it over here, watch the position offset change. So now you can see that also changed the line as well. So, well, that's it for position. But we also want to do rotation. Now this one's a little bit more complicated. So we're getting so we want the transform rotation relative to target. So what we need to do is quaternion.inverse target.rotation times transform.rotation. Oh yeah, so we want to do, I recently learned that Euler angles actually converts the quaternion. Any quaternion, A dot, like you have Euler angles. So, if we rotate this, now look at the rotation offset. You can see we got a bit of an offset. Now let me actually see one thing really quick. So let's set the offsets. Okay, so that does actually still remain working. Sometimes this doesn't always work. Sometimes the editor stuff resets on play. And here's what to do about that if that happens. Editor utility, using unit editor, .set dirty this. And that would actually, that's actually going to get the changes. But I'm not actually going to do that. We don't need to do that. So that's setting the offsets. So now we're going to do a set position and rotation. And it's actually this same code. We're going to put this code into another function that we can call. So now we're putting it in here, the set position and rotation, and it's going to show up being right-clicked once we save the changes and it compiles. So now, setting position and rotation, but nothing's happening on late update. So let's call set position and rotation. So all I've done was moved this previous code. This code was in late update, and I moved it into this function, and then we're calling the function instead in late update. And now we can also call that function in the inspector. Okay, so if we move the camera over, set position or rotation, should position and rotate right to it. Just like that. So now let's give it another play. We should be able to. So yeah, we should be able to again rotate this object, watch the game view again, and it maintains position and rotation completely. It's based on these position offsets. All three of these matter. All right, if we change the position offset, we drag it up, we drag it down, it moves like so. The Z offset is completely relative. The Z rotation, you can do that, or do that, or you can do that if you want, but you probably want to have this as zeros. But that's just in case you want to have it different. Well, actually, maybe you might actually want this to be rotated down a little bit. You might actually want a camera that actually is up kind of high, and that rotates down. And we can still rotate the cube, and it maintains its rotation. Yeah, and it rotates along the pivot. It's kind of an illusion in some sense. And the main camera is not a child of the cube. I mean, that is one way you could do it, but I like this method better. And I haven't found any other tutorials that actually go over this. Now, there probably are tutorials for, like, the general transform point and stuff, but this is actually the way you should do it. So yeah, that's pretty much all for making the camera follow the object. I hope you guys enjoyed this tutorial, found it helpful, and I'll see you all later.